Okay guys, we are in LGCSE revisions mathematics. We are looking at numbers and language. So guys, let's start revising guys, because the exams are just right here. They're just right here. They're just right here. There is no time to waste. We have to be vigilant enough guys to revise as much as possible. All right. We will be looking at a few questions that are common in exams, both for core and extended students. So let's pay attention. I would love you to have an exercise and a pen nearby or pencil so that you can scribble down some things also. All right. Okay, guys. Now, let's say a question. There is a question here which says, uh, uh, where without a calculator, work out the following. Without a calculator, work out the following. All right. Without a calculator, work out the following. Okay. So this question will appear, say, in paper one or paper two. Paper one for core, paper two for extended. Right. Now, you don't use a calculator there. So now the question is the square root of um, the square root of 5 and 4 over 9. The square root of 5 and 4 over 9. How do we work this out, guys? So the first thing for you to do, guys, is to change this into a vulgar fraction, this one. We're going to say 9 times 5 is 45, plus 4, that will give us 49, okay? So we are going to have 49 over 9 square rooted. And now you can say, all right, when I'm here, I can just separate the square root of the numerator alone divided by the square root of the denominator alone. Now, the square root of 49 will be what? It will be plus minus 7 over the square root of 9, that is plus or minus, what else? Plus or minus 3. So that means our answer is plus or minus 7 over 3, which could be plus or minus 3 into 7 goes twice, and it leaves 1 over 3. So that is the square root of this number. I hope you are happy, guys. Or sometimes you would say, okay, I will say this is equal to, when you get here, you say, okay, I have 49 over 9 to the power half, because you know that the square root of a number is the same as that number to the power half. All right. So now we have written this as in an index form, right? Let's write these numbers inside also in index form. So that would be 7 squared. 49 is the same as 7 squared over 3 squared in index form, all to the power half. All right. So now this is going to be, we are going to distribute the power half into this fraction here. So the power half will multiply both the power of the numerator and the power of the denominator. So we are going to have 7 squared over 3 squared. But now we will have the powers multiplied by half, the power here multiplied by half as well, the powers. So that means now this is going to cancel, and here this cancels. 1 times 1 is 1, so you are going to have 7 to power 1, okay, over 3 to power 1, which is the same as 7 over 3, which will give us this also. You will just add plus minus because you know that the square root of a number could be positive or negative. Okay, now that is it, guys. That is it. That is it. Now let's look at this one. Let's look at this one. It's basically B. It's the same concept, guys, and you will finish it up on your own. B, the cubic root of 15 and 5 over 8. What do we do, guys? The first thing, guys, is to work out this, turn this into a vulgar fraction. So 8 times 15 is going to be what? 8 times 5 is 40. Put 0, carry 4. 8 times 1 is 8 plus 4 is 12. So plus 5. So that is 125 over 8. So we are going to have the cubic root of 125 over 8. All right, that's easy. Now, what does this mean? This means now that we can do this. I want us to use this method. This one you will do on your own. We have 125 over 8 all to the power 1/3, because the cubic root of a number is the same as raising that number to the power 1 over 3. This is equal to, let's write these numbers in indexed form, both the numerator and the denominator. This, the numerator will be 5 cubed over 2 cubed to power. Now, this is going to be 5 to power 3 over 2 to power 3. Now, each power is multiplied by 1 over 3, so they cancel. Multiply by multiply the powers, okay? They cancel. So you are going to have your answer as 5 over 2. You can even make it 2.5 if you like. Okay? So that is it, guys. That's how we do this. That's how we do this. All right. That's how you work those numbers without without a calculator. All right. Okay. Let me remove everything. Let me remove everything. Okay. Now we have another question here. It says, state whether each of the following is a rational or irrational number. So this question is talking about rational or irrational number. Rational, rational number versus vis-a-vis irrational number. What's the difference between rational and irrational numbers? So rational numbers can be written in the form A over B. They can be written as a fraction. But the irrational number cannot be not written as A over B. An irrational number cannot be written as a fraction. Let me give you an example. When if we talk of pi, it's 3.142 till it's an infinite. It doesn't end. Okay, so this number, because it cannot end, you can never make it a fraction. Okay, such numbers are irrational numbers. But if you have, say, 3.5, but below the point you put 1, below this digit you put 0, so it becomes 35 over 10. So 35 over 10 is like this, the rational number. But for this one, if you try to do that, you would put 1 over the decimal, 0 for this, 0 for and which one is irrational. We have 5, the square root of 5 times the square root of 2. Is this number rational or irrational? Is this number rational or irrational, guys? Okay, let's try to simplify it. This is the same as saying the square root of 5 times 2, which is actually the square root of 10. All right. So is the square root of 10 rational? You can decide. You can use a calculator. If it doesn't stop, if it doesn't stop, it's a decimal number that does not stop. It's irrational. Okay? It's irrational if it's like that. Now, I bet it's irrational, this one. Let's look at this one. Another number is the square root of 64 divided by 4. Is this number rational or irrational? Let's simplify it. The square root of 64 is plus or minus 8 divided by 4. That means the answer is plus minus 2. So this plus or minus 2 can be written as plus minus 2 over 1, which is in this form. So it's rational. Okay? So this one is irrational, this one is rational. Press the calculator. This one will give you indefinite decimal, so it's irrational. Okay, guys. The next one that I want us to look at is the reciprocal, writing numbers or writing a reciprocal of a number. Writing a reciprocal of a number. Write the reciprocal of. That's the question. Reciprocal. Write the reciprocal of. Reciprocal. So what is the reciprocal of 7 over or 2 over 7? What is the reciprocal of 2 over 7? What is the reciprocal of 2 over 7? What is the reciprocal? The reciprocal of A is 1 over A. The reciprocal of A is 1 over A. That means when they say write as the reciprocal, they just want you to divide 1 by that number. To say 1 over that number. 1 over any number gives you the reciprocal of the number. All right? So that means here we will have to say 1. This would be 1 over. This implies the reciprocal of this implies 1 over this. So This is the same as saying you are saying 1 divided by 2 over 7. Is that so? Now this is equal to 1 times 7 over 2. We just change division into multiplication and we turn this fraction upside down. Okay, we flip it. So this becomes 7 over 2. So the reciprocal of 2 over 7 is 7 over 2. You just flip it. Now, what is the reciprocal of this number, 13 over 6? What is the reciprocal of this number? Okay, it's obvious. 2 over 7 reciprocal is 7 over 2. So the reciprocal of 13 over 6 will be 6 over 30. Simple. You just turn it upside. If you say 1 divided by 13 over 6 is going to give you 6 over 30. That's the reciprocal. So meaning that if you are going to find the reciprocal of a number, you just flip it if it's a fraction. All right. If they ask you to find the reciprocal of 2, what would you do? The reciprocal of 2, we know that 2 is the same as 2 over 1. So its reciprocal would be 1 over 2. You just flip 2 over 1 into 1 over 2. That's as simple as that, guys. I hope you understand. Now, this is one question that I wanted us to look at in our revision. Prime factors. Prime factors. Prime factors. Okay, the question is on prime factors. Product of prime factors, I mean. Product of prime factors. It says, list the prime factors of these numbers and express each number as a product of its prime factors. Prime factors. Okay. Well, the first number is 48. What are the prime factors of 48? We can list the factors. Let's start with the factors. Then from the factors, we take out prime numbers. Those numbers will be the prime factors of 48. Let's get the factors of 48, guys. Factors of 48, they would be 1, 2, do we have 3? 48 divided by 3, yeah, it's 16. 3 times 16. Do we have 4? Yes, 4 times 12. 5, no. 6, yes. It's 6 times what? 6 times 8, I think. Huh? Let's see. 6, we have 6, 12, 6, 12, 18, 24, 30, 36, 42, 48, yes. 6 times 8. Now, 8, 12, 6, and 20, is it, what is it? Is it 24? Yeah, 24, and then 48. All right. So what are prime factors here? They are all factors, but we need to select only those that are prime. It's this one and this one only. Those are the only prime numbers within this factor. So now, when we list the prime factors of 48, we would say there are 2, 3. Those are the prime factors of 48. But when we write 48 as a product of its prime factors, product means multiplication. So we are going to write 45 as a multiplication of its prime factors. We write 48 as a multiplication of 2 and 3. So let's see what we can do. 48 is equal to 2 times 24, which is equal to 2 times 2 times 12. Are we aware? 24 is 2 times 12. I'm just trying to get out the 2 there. which is 2 times, then it's 2 times 2 times 2 times 2 times 3, that is 6. So that is it. This is the product of the prime factors of 48. 48 as the product of its prime factors, or you can write it as 2 to the power 4 times 3. It's 5. It's still the same. All right. Okay, guys, this is the end of our revision session. We will be continuing with revisions from several topics in our mathematics syllabus. So